Alright, so this lesson is about polar coordinates, which is just a different way of representing the location of a point. So the first problem here should be one that you're familiar with. If I asked you to graph in a rectangular coordinate 3, 4, that'd be over 3, up 4, the dot would go right there. With a polar coordinate, I'm going to put it in the same position, but the position of it is determined by two other factors. It's not the horizontal distance and the vertical distance like a rectangular coordinate. Instead, its location is determined based off of what we call a polar axis. So that is drawn through at a certain angle. So right now we're going to call this as the polar axis. And it's at a certain angle, which is where the theta part of the coordinate comes from. The other part of it is how far it goes out from what's called the pole. The pole is this middle part here, so that's the pole. And the polar axis has a positive side and a negative side determined based on where the terminal side, where the angle stops is. So this theta stops there, so the top part would be the positive, the bottom part would be the negative. If we went further around and it stopped at the bottom part could be positive and the top could be negative. The other part of the coordinate then is the r. The r is your distance that you're moving out. So that right there is r. So r is the distance from the pole to the point. If you look at it, it's really just the number of circles you move out. That's what we're looking at. It's like the radius. I'll put there. It's like the radius. How many circles out you move from the center. And then I already filled in theta. Theta is the angle of the polar axis. And I alluded to this a little bit, but the r determines which side of the polar axis you go on. If r is bigger than 0, you're going to go towards the positive side, which is the terminal side of where the angle stopped. And if it's less than 0, you're going to go to the negative side. So we've got some examples on the next page to help you understand the graphing part. So I put the steps to graphing on the right-hand side. It says that when you graph these, usually when we graph x and y, we graph x first, then y second. These we're going to go in the other order. You're actually going to start with the angle. So we're always going to start with whatever theta is, and we're going to graph that first. So you do need to locate these. If it helps to take your plate out, you can locate them, or you can renumber your axis with common denominators. This is 0. This was pi over 2. So it's really going to be 3 pi over 6 if we get that common denominator. This next part would be 6 pi over 6. This would be 9 pi over 6. This would be 12 pi over 6. Or if you look on your plate, 11 pi over 6 happens to be one on the plate. It would be right here is where the angle would go. So that's all the way around this side, which makes this the positive side of the polar axis. And then there would be another part that goes the other direction, which is going to be the negative side of the polar axis. Then to plot the point, after we've graphed theta and made the polar axis, we've made both sides, labeled them, the other part of the polar coordinate is the 4. The 4 tells me how many circles we're going to move out. And since it's a positive 4, we're going to move in the positive 4 direction. We're going to go out 4 circles. And the point's going to go there. 1, 2, 3, 4. Oh, no, 4. Okay? So now if you look at the next problem, we're again going to start by graphing that. This one's negative, so we're going to have to go the other direction. This is 0, this is negative 2 pi over 4. This is negative 4 pi over 4. This is negative 6 pi over 4. So negative 5 pi over 4 would be right through the middle of this one. That's going to be the positive side, and then it's going to point the other way. That'll be the negative side. This one then, we're going to stay on that polar axis. We have to move in the positive direction too, so that's 2 circles out. So it's going to be right here. That's where the point's going to go. So you're just trying to find the location of the point. All right, number 3, we're looking at pi. So I know 0, pi over 2. Pi is going to be over here on that left side. And it's going to land, the polar axis then is on what originally would have been the x-axis. So, but this is the positive side now, because that's where pi goes to, that's where we would stop. And this is the negative side. So the fact that we want to go in the -2 direction on that means now I need to move on towards the negative side. So I'm going to go this way, 2 circles, and that's where my point's going to be. So you have to keep track of your positive and your negative based on where the angle stops. Wherever you would draw that angle, that's the positive side. So if you want to, if you've opened up the notes, if you want to pause at this point and try number 4, I had everybody in class try number 4. And now I'm going to talk through it. So in number 4, the angle is where we're going to start, 2 pi over 3. That is in the second quadrant. That's my positive side. My negative side is going to be down here in the fourth quadrant. And then the r this time is negative again, so we're going to move towards the negative side, where I labeled it as the negative side because this is where the angle stops. That was the positive side. This is the negative side. We're going to go out 3 circles, and the dot would go there. So hopefully the graphing part makes sense, so that what we're going to do on the next page will make some sense as well. So what's really interesting about polar coordinates, what makes them different from rectangular coordinates, is that you can represent the same point in more than one way. So when we do rectangular coordinates, there's only one representation. If I look at a point, there's one answer that everybody can give me. It's going to be the same answer. But for polar coordinates, because we're talking about angles, we can have extra rotations that would stop at the same point. And even bigger than that, we could go halfway, so the extra rotations would be adding on 2 pi. Let me talk about that first. The other thing we could do is we could go halfway around, which is just pi, but if you notice, if we go halfway around, we're going to have to change r so that it gets directed the right way, because if we went halfway, it'd be on the wrong side of the polar axis, but if we change r, it'll go on the other side. So the formulas for these is that we're going to take, again, just to reiterate, if we can keep r the same to find another representation, and we can add or subtract 2 pi. Or your other option is you could change the r, and then if you change the r, you would add or subtract pi to find another representation. So what you do have to be careful about, according to the directions in this next example, is we have a certain space that we need to be between. We need to be above -2 pi, but we have to stay under 2 pi. So the first thing I'm going to do in this first example is graph it. So we know the pole is going to be tilted at the angle pi over 6, so that's in the first quadrant, that's where it's positive, and then the negative part will go this other direction. And then we're going to go out 3 circles in the positive direction, and that's where our point's going to be. So what the problem's asking us for after we graph it is to come up with 3 additional representations of it. So to get 3 additional representations, one of our options is to keep r the same and take pi over 6, that original theta value, and we could add 2 pi, but if I did that for this example, it would get too big. So my other ability is to subtract 2 pi. And in order to do that, you really do need a common denominator. So if we change that to be out of 6, it would be 12 pi over 6. And then if I subtract it, I'll get 11 pi over 6. So one point that would stop, what we're looking for is the one that would stop at the very same exact position, would be 3 comma negative 11 pi over 6. So if you think about that, negative 11 pi over 6 is going to go this other direction, but it's going to have that same stopping point, and it would go 3 out in the positive direction, so it would stop at that same point. That's what we're looking for. We're looking for another representation of the point that would stop in that same section. So then the other option, we've exhausted the ability to either add 2 pi or subtract 2 pi, is to add pi instead. But when we do that, if we look at the picture, if I were to add pi, we'd go this way. I'm going to end up on the other side of the pole, and I don't want to be on that side, so if we're going to add pi, we actually have to make the r negative so that it will end up back on the correct side. I don't want to end up here, I want to end up over where the red dot was. So, we're going to change the r to -3, since we're thinking about using pi. And then we are going to add that pi on like we talked about. So it'll be that original value, pi over 6, plus pi, and in order to add those they have to have the same denominator, so that's really pi over 6 plus 6 pi over 6. So we get an answer of negative 3 comma 7 pi over 6. The last option that we have is that we could go the other direction halfway, so we'd only go pi. That's again going to put us on the other side of the pole. So we're going to have to change r to negative 3, but this time we're going the other direction with pi, so we're going to subtract pi. So then that's negative 3 pi over 6 minus 6 pi over 6. So we get negative 3 comma negative 5 pi over 6. So those are our three representations here of the same point. Those are all going to stop at the red point, but there are different ways to get there. Alright, so then in number 2 it just gets slightly more complicated because this one is closer to being 2 pi already. So let's graph it first. So we have graphed the pole first at 5 pi over 3, that's in the fourth quadrant. And this is the positive side and this is the negative side because it would rotate all the way around to here to get to the fourth quadrant. But for this one, the r is negative, so we're going to move out negative 1, and we're going to be right here on that first circle. So if I want to generate the one that would be the same value for r, I'm going to have to rotate the other direction. So in order to do that, I have to use 2 pi, so I have to go the whole circle around. So it's going to be 5 pi over 3. I can't add 2 pi because that would make it way, way, way too big, so I'm going to subtract 2 pi. So that's negative 1, 5 pi over 3, minus 6 pi over 3. So we get negative 1 and negative pi over 3. That's one representation. The other representations I'm going to have to use pi for. So I'm going to use positive 1. I'm going to switch it to a positive 1, and then I can subtract pi from here. And then that's going to be 5 pi over 3 minus 3 pi over 3. And I'm going to get 1 and 2 pi over 3. And then this one, we couldn't add, the last one we were able to add pi to get our third one. We can't add pi to the original because that would also make it too big. So we're going to have to subtract pi or 2 pi again from one of these. So it kind of depends on where you want to start. We could either do the teal one and you could subtract 2 pi from it to get the next answer. If we subtracted pi, it would just give us the purple answer. Or we can take the purple answer and we can subtract pi from it. But you're going to have to use one of those answers to generate your third here. So I'm going to use this one. I'm going to subtract pi from it. So it'd be 1, and then it'd be negative pi over 3 minus pi. Since I'm subtracting pi, that's why it changed to positive 1. And then that'll be 1, comma, negative pi over 3 minus 3 pi over 3, which is 1, comma, negative 4 pi over 3. So there is your third representation of that point. Alright, on to the next.